So that's the explanation for why the potential energy due to gravity is equal to the kinetic energy on the side of potential energy due to spring. And then we're gonna have to solve for potential energy due to gravity and potential energy due to spring. Simple formula for potential energy due to gravity: m times g times h, mass times gravity times height. That will give us 5.88 joules. Joules obviously being the unit for energy. And then potential energy due to spring, half k times x squared, half of k, which is our spring stiffness constant we solved for earlier, and then x squared, which is the displacement, and in this case we'll be using 3, not 0.03, because this is the object as a whole, and that will give us 294 joules. And then we'll plug this into our equation of the conservation of energy. This right here is potential energy of spring, which we solved for, 294. This is KE1, which is equal to potential energy due to gravity, which is 5.88. So both of these will be 5.88, and that will give us a second value for kinetic energy, 294 joules. And now we're gonna have to use the formula of kinetic energy to find our velocity, as that is the only equation that pertains to springs that does have velocity. But we'll need to plug in a value for kinetic energy, and we have two different values. So what do? Plug in both? Nope. Which value do we use? The answer is we'll use the value that is 5.88. And why, you may ask? Because this is the value of kinetic energy that is on the same side when the rocket has potential energy due to spring, and that means that it is in motion, so it will have a velocity. So we'll plug 5.88 into the equation for kinetic energy. Ke equals half m times v squared. 5.88 for kinetic energy, we have our half. Mass is 0.2 and velocity is unknown. We'll solve this. Half times 0.2, that will give us 0.1. Divided 5.88 divided by 0.1 give us 58.8 equals v squared, square root of both sides. That will give us 7.67 meters per second as the velocity of the rocket. A quite simple process, but knowledge of how different parts of the spring topic relate to each other is indispensable to be able to solve such question. So there we have it. We solved for our spring constant and for our velocity using our knowledge. Thank you.